In this video, we will discuss the time interval measured by which frame of reference should be taken as the proper time interval when using the time dilation formula. See the time dilation formula. In this formula, delta t0 is known as the proper time interval. There are two inertial frames and there are two events. The time interval between the events is measured by the clocks of both the frames. The question is the time interval measured by the clock of which frame should be used as the proper time interval. I wanted to address this problem because there are many YouTube videos teaching wrong things about this. Some videos say that the time interval measured by a clock in S prime frame is the proper time interval. But this answer does not help because the question may not say which frame is S prime. And even if it says, it may not use the same rule for naming the frames as used in your textbook. And some other videos say that the time interval measured by a clock in the moving frame is proper time interval. This is also a wrong answer because both frames are moving relative to each other. And even if the question mentions which frame is moving, then also that cannot be used to find which time interval is the proper time interval. We will find the answer by considering two problems. Problem 1. A bus is moving at a speed of 0.8 times the speed of light on a road. A child inside the bus drops a ball on the floor of the bus. The ball bounces. The child catches the ball and drops it again at the same spot. The time interval between the two collisions is measured by the bus frame and also by the road frame. Which of these two values of the time interval is proper time interval? Problem 2. A bus is moving at a speed of 0.8 times the speed of light on a road. A child on a side of the road drops a ball on the road. The ball bounces, the child catches the ball and drops it again at the same spot. The time interval between the two collisions is measured by the bus frame and also by the road frame. Which of these two values of the time interval is proper time interval? In problem 1, a child inside the bus is dropping the ball, and in problem 2, a child on the road is dropping the ball. In both these problems, assume that the bus frame and the road frame are both inertial. In reality, they are not exactly inertial, but for the sake of these problems, assume that they are. Or if you want, change the problems to replace the bus frame and the road frame by any two inertial frames. Pause the video and see if you can find the answers. Let us find the answers. Call the first collision of the ball with the floor of the bus or the road, as the case may be, as event 1, and call the second collision as event 2. In problem 1, the two events happen at the same location in the bus frame. This is because that the spot at which the ball is dropped is at rest in the bus frame. So the two events happen at the same location in the bus frame. But when seen from the road frame, the entire bus is moving. Together with that, the spot at which the ball is dropped, that is also moving. So the two events are happening at different locations in the road frame. In problem 1, we call the time interval as measured by clocks in the bus frame as proper time interval. That is because the two events are happening at the same location in the bus frame. But in problem 2, the two events happen at the same location in the road frame. So we call the time interval between the two events as measured by clocks in the road frame as the proper time interval. So we take the time interval between two events as measured by clocks in that frame as proper time interval in which the two events happen at the same location. But the question is why? How are we so sure that this method will work? The answer is related to how we derive the time dilation formula. One of the ways to derive the time dilation formula is to start from Lorentz transformation equations. Consider two inertial frames S and S prime. S prime is moving at velocity v relative to S along the x-axis. The x and x prime axes always coincide. Y and y prime are parallel and z and z prime are parallel. Both the frames set their clocks to 0 when their origins coincide. Then you get these 6 Lorentz transformation equations. In these equations, x, y, z, t are the coordinates of an event in frame S, and x prime, y prime, z prime, t prime are the coordinates of the same event in frame S prime. This means there is an event which is happening at location x, y, z and at time t as seen from frame S, and the same event is happening at location x prime, y prime, z prime and at time t prime as seen from the frame S prime. I have put another video in which I have shown complete derivation of the Lorentz transformation equations. If you want, you can see that video. I have put the link to that video in the description. We will use this Lorentz transformation equation, which we called as equation 2b. Consider two events. Their coordinates are x1, y1, z1, t1 and x2, y2, z2, t2 as seen from frame S, and the coordinates of the same events are x1 prime, y1 prime, z1 prime, t1 prime and x2 prime, y2 prime, z2 prime, t2 prime as seen from the frame S prime. Substitute these coordinates in equation 2b, then this is the equation you will get. So we get this equation, which I am calling as equation A. Call T2 minus T1 as delta T and T2 prime minus T1 prime as delta T prime. Assume that the two events happen at the same location in frame S prime, that is x2 prime equals x1 prime or x2 prime minus x1 prime equals 0. Substitute these values, then you will get equation B. Next, call delta t prime as delta t0. Then you will get the time dilation formula. As you can see, we called the time interval measured by that frame as proper time interval, that is delta t0, in which the two events happen at the same location. Note that it has nothing to do with the names of the frames. It also has nothing to do with which frame is moving. After all, both frames are moving relative to each other. To summarize, the time interval between two events measured by clocks in that frame is proper time interval delta t0, in which the two events happen at the same location. We follow this rule because this is the rule we follow when deriving the time dilation formula. I have put another video in which I have derived the time dilation formula and explained it in more detail. If you want, you can watch that video. I have put the link to that video also in the description.